Its construction has been called the greatest public works program in the history of the world. From the extensive interstate system that crosses the mountains, weaves through the valleys, and passes the plains, to the arteries that reach deep into the hearts of the cities. From the highways that stretch through the deserts, roadways that cut through the rocks and routes that wind along the rivers, to the corridors and connections that lead to favorite destinations. Wherever they're going, the motoring public expects good roads. They want a smooth ride. They deserve a safe and reliable transportation system without any undue delays. For the highway community, that takes a change in philosophy, from the old mindset of waiting for the worst, to a new strategy of keeping good roads good. Preventive maintenance. And the biggest challenge? Project selection. It's got to be on the right road, with the right treatment, at the right time.
Times are changing. It's no longer constructing roads. It's about preserving and maintaining the roads. It's about working with the state agencies and contractors and suppliers to get out and do preservation treatments at the right time so that we effectively extend the service life, improve the quality of service for the traveling public.
Preventive maintenance is a tool for pavement preservation. Unlike routine maintenance that involves regularly scheduled activities, preventive maintenance is a strategy which is planned. It is not reactive maintenance intended to keep a pavement at a particular level of service. Rather, preventive maintenance applies quantifiable, cost-effective treatments to preserve an existing roadway, retard future deterioration, and improve the functional condition of the system. And unlike rehabilitation, which restores a pavement structure, the goal of preventive maintenance is to extend the life of structurally sound pavements.
We all know that we don't wait until the wood is rotted before we paint our house, and the same philosophy should be true with pavements. We should apply a preventive maintenance treatment while the pavement's still in good condition.
You got to make sure that you have adequate structure of the pavement. Otherwise, it will not last very long. If you put a micro seal or a thin overlay over a pavement that is not in good structural condition, in a year or two, you're right back to where you were with the same problems.
Although a variety of treatments may be used appropriately in a preventive maintenance program, the same treatments do not constitute preventive maintenance if applied as a stopgap measure simply to delay needed rehabilitation.
Just because we're doing a particular preventive maintenance treatment does not mean that it's preventive maintenance type of work.
True preventive maintenance requires selecting the right road, choosing the right treatment, and applying it at the right time. To do this requires, first, an evaluation of the current and past conditions of the road. Typical condition measures used to assess deficiencies in a road include distress, or the amount of cracking, roughness, or ride quality, deformation such as wheel rutting in flexible pavements, or amount of faulting of rigid pavements, and the amount of friction or skid resistance. In the past, measuring distress has often been a way of finding failure. Now, the goal is to prevent failure from occurring.
For preventive maintenance, we need to get on our condition surveys earlier. We need to use preservation type indicators, which we may not even have fully defined as of yet.
Indicators may include oxidation, a change in surface texture, or evidence of the loss of fine materials. In Georgia, annual surveys of flexible pavements involve a visual inspection and a written recording of maintenance-type indicators, as well as traditional condition measures.
So you're really assessing the extent or the amount of the cracking?
The amount and the extent and the severity of the cracking is what we're keying in on. That's very important. For our program to work, a thin asphalt overlay mainly or a chip seal, We want to catch it at an early stage of deterioration. We're not so much worried about the size of the crack as we are the appearance of the crack and the pattern. In this part of the state, because of the clay soils, we don't want the moisture to get under the roadway and weaken the structure. So with thin overlay, if we do it early enough in the life, will give us long-lasting service.
In this example, the cracking is more severe and widespread. The pavement's condition has deteriorated beyond the threshold for preventive maintenance.
Preventive maintenance are things that protect a road surface before you start seeing alligator cracking. You need a preventive maintenance treatment, a reclamite, a fog seal, a slurry seal, micro pavement, something to, even a chip seal, to restore the sealed surface of your highway before you get intrusion of water there. And sometimes that seal could come early on after a new overlay.
Early evaluation and treatment is equally important for rigid pavements. A number of states use an automated system, as in this example of surveying rigid pavements in California.
Starting to pick up a little bit of faulting in that number 5 lane though.
Caltrans uses a driver and a pavement evaluator. The driver drives the vehicle and is responsible for the crew's safety and the traveling public safety. And the evaluator sits behind the operator or the driver, looks out the window and inputs the distress seen from the outside 2 lanes in each slab directly into the computer. And the traffic conditions with the high truck traffic create an enormous impact on our highways. And that's one reason Caltrans looks at the outside 2 lanes, because that's where the majority of the truck traffic goes. That's where we can focus our work and come up with a very good analysis of the conditions of our highway that way.
Some of the things they look for are faulting, spalling, a sound pavement structure, and proper drainage. Drainage that works correctly will keep water away from the riding surface and protect the pavement structure. The condition of the seal in the joint between a concrete pavement and asphalt shoulder is another key indicator for preventive maintenance.
As you're looking at these pavements, our goal is to gather accurate pavement condition surface data. And the data collected, it's very important that it remain consistent and accurate throughout the entire network. So we have a very intense training period to make sure that all our raters look at the highway in the same manner and log the data in the same way. Management is able to look at that and find out where preventive maintenance strategies would be best applied.
You have to have the data, the collection of the pavement distress, the traffic volumes, all those kinds of things that go into making decisions on, what is the condition of the pavement out there.
By evaluating current and past conditions, agencies can determine whether or not a pavement is a good candidate for preventive maintenance. Pavements that show rapid rates of deterioration may not be good candidates.
But certainly there are those roads that we'd be better off, or the owner agencies would be better off, to leave them alone, let them deteriorate, put the money where it counts.
Where it counts is on structurally sound pavements in good condition that show normal or slower rates of deterioration. Such pavements are ideal candidates for a preventive maintenance treatment. Using the pavement condition data, agencies must then determine the optimal time in a pavement's life to apply a preventive maintenance treatment.
Well, I feel timing is critical to preventive maintenance. Early in a pavement's life, we can do our less expensive treatments and we can get some very cost-effective results. If we wait too long on a roadway and then apply a treatment, it may not be cost-effective and it may not really extend the pavement's life.
You'll feel like you're doing something to a brand new road. Why should I do this? But it really helps in preventative maintenance. You won't see too much distress. That's when you do it. You don't wait till it's too late.
Once a candidate has been identified and the preventive maintenance project has been designed, it's important to act quickly to get the work done. The window of opportunity is brief, generally within 1 year of pavement selection.
because you could have a good solution, but if you don't get out there and do it in the right time frame, then it no longer is the right solution for that road.
We turn them around pretty early. We identify the needs, and then we go ahead and let them to contract and get them done early.
Selecting the right treatment is an equally important element in an effective preventive maintenance program.
You have to have a number of different treatments and applications that you routinely consider. There is no one treatment that's going to fit all roadways, all pavements, all the time.
There's a lot of factors that go into determining what treatment should be used. One is the availability of a contractor.
And just as important as an industry balance, are we using the resources in the workforce around us effectively?
And it's not unusual that contractors can help us by providing insight into maybe better techniques.
Maintenance factors, how durable is the process we put out there?
How long will it extend the life of the underlying pavement?
So I think it would make a difference on the pre-existing condition of the pavement you're going over.
Is this going to work with the kind of loading that we're looking at in California?
Each state has to tailor a preventive maintenance program that's going to meet their needs.
We perhaps don't need to place those expensive treatments on a low-volume road.
We have a lot of traffic to deal with. We can't afford to shut down a freeway.
Operational considerations or even funding and policy considerations.
We're just trying to provide the motorist with a very smooth, efficient riding pavement.
States like Michigan, we're more concerned with a freeze-thaw.
It depends on climate, climatological effects.
The environmental effects have a tremendous impact on what treatments used.
Assessing the performance of different treatments under different conditions will better equip an agency to select the right treatment at the right time. The Strategic Highway Research Program has mapped out 4 environmental zones related to long-term pavement performance: a wet climate with freezing temperatures, wet with non-freezing temperatures, a dry no-freeze zone, and a dry climate with freezing temperatures. The environmental effects in these different zones will cause pavements to display different condition deficiencies at different times, thus requiring different treatments.
What causes the most deterioration to pavements and to roadways is the intrusion of moisture into those pavements. When you have freeze-thaw cycles, what happens is the moisture gets into those nooks and crannies, and because when it freezes it expands, it actually makes those nooks and crannies wider, and you end up with more moisture in your pavements, and that's the enemy, is moisture.
Even within an environmental zone, there may be several microclimates with conditions and effects that can vary widely.
Well, we have the desert, so you have the hot temperatures. You have the coastal environment, so you have the fog and the lower temperatures.
And in each one of those microclimates, building materials and strategies for maintaining our highways varies a little bit so that you can cope with the conditions.
So we're looking at the environmental sides, and then we're also looking at the traffic loading sides. We're looking at the vehicles, and the number one vehicle we're looking at, of course, are trucks. Trucks do most of the damage to the road.
By the very nature, pavements that are subjected to greater traffic volumes and heavier loading are more apt to deteriorate than roads that are not. And so we need to look at those traffic conditions to determine what may be the most cost-effective treatment available.
Agencies generally break preventive maintenance treatments into 4 broad groups: the least costly crack and joint treatments, surface seals in the moderate price range, the more expensive functional pavement enhancements, and minor rehabilitation techniques.
Common definitions of preventive maintenance and pavement preservation are not cast in stone. We're still trying to work towards commonality in our definitions, and that may take us a year or 2 longer. but it doesn't mean that the common groupings of these treatments wouldn't be somewhat similar in most states.
The following examples relate various environmental and traffic conditions, pavement types, and efficiencies to the 4 treatment groups.
Well, this pavement is a relatively new pavement. It exhibits a very few cracks. It's got an excellent cross-section. And the cracks are well defined. They haven't deteriorated to the extent that another treatment other than crack sealing would be considered. And what we're attempting to do is keep the water out of the underlying base by sealing cracks. And we're doing that by routing the cracks, creating a reservoir, blowing the reservoir clean, and then putting in sealant.
Crack and joint sealing can only be effective if the right sealant is properly applied. Joint sealing on rigid pavements can help prevent the infiltration of water in wet climates and prevent the intrusion of incompressibles that interfere with the expansion of slabs in hot temperatures. Surface seals include both hot applied and cold applied treatments such as fog seals, rejuvenators, slurry seals, microsurfacing, and chip seals. Chip seals and slurry seals are similar in benefits. Both add a protective surface with good skid resistance, retard oxidation and raveling, and reduce the infiltration of water into the pavement structure. Proper curing and speed control is required with chip seals in order to reduce windshield damage to vehicles.
The products that we deal with, the chip seal is by far the most temperature sensitive in that it needs some warm weather for a few weeks after to get into good shape to keep the asphalt live. If you have real cold weather right after you put a chip seal down, you'll have problems with it generally. Some of it will come off, you'll have to redo the following year.
Applying a surface seal early in a pavement's life will protect the pavement from the effects of oxidation.
In areas where you have a lot of sunshine and it's dry, you'll see more oxidation than you will, of course, in areas that are more shady or more temperate in climate.
Well, oxidation is when the asphalt gets real old and brittle and becomes hard. It's a factor, especially in the southern part of our state, where we get oxidation cracking because of the brittleness.
To reduce the incidence of reflective cracking, preparatory crack filling is recommended before applying most surface seals.
Basically, the more preparation, the better the road is. These seal coats aren't going to make the road any better than what it is already. And what they're going to do is protect what's there. If the road's in good condition, it'll protect it and keep it in good condition.
The slurry seal is a good example of how it treats a pavement which was in pretty good condition. The slurry seal which we put on here, for the most part, after 10 years of life, is still holding up very good. There's a few cracks which have come through which need to be sealed up, but for the most part, the wearing surface is still tight.
Particularly in urban settings, treatment selection must take traffic conditions and congestion into account.
Well, the city decided that they needed something that they could get in and out of the areas rather quickly. They had a lot of pavements that were worn but structurally sound, and they just needed to add a new surface life to the existing pavements. But yet they also wanted to add something with a high skid resistance to the pavements for wet weather traction.
The chemical reaction in microsurfacing forces the moisture out of the system so it chemically cures in about an hour, rather than relying on the ambient air temperature for curing.
In about 5-10 minutes you could walk out across it, and what you actually see is a wetness on the surface, and it's not the asphalt wetness that you're feeling, it's actually the water being pumped up out of there. And if you patted your hand on it, you could get clear water on your hand and no asphalt.
In the southwestern United States, pavements subjected to wide temperature swings have been shown to benefit from the application of asphalt rubber products used in both chip seals and thin overlays.
Well, I think most people will agree that anytime you have an asphaltic pavement and there's thermal conditions, you're going to have thermal cracks. I'd like to show you why asphalt rubber binder works so well both in chip seals and hot mix. It's probably about less than 80 degrees today, and you get this real wide band of binder that stretches out. And it has a tendency to want to hold things together and resist reflective cracking.
Roads in a later stage of deterioration will likely require more expensive treatments in order to extend pavement life.
We look at certain preventive maintenance treatments as functional enhancements. That is to say that they actually improve the ride as well as reduce the level of distress in the pavement. A good example is a bituminous overlay or a concrete pavement repair.
All right, what you're seeing here is a thin overlay over an existing pavement. Now, this is a typical treatment for most of our state routes in the state of Georgia, regardless of the traffic level, unless it's an interstate. This will last on an average of 10 years or better.
In Atlanta, most highway work is done at night during non-peak hours. A treatment that can be done in stages, a lane at a time, allows all lanes to be open to traffic during the day, often the only choice in urban areas with extremely high traffic volume.
If we let this road go and have to do major rehab, we'd have to shut down at least 2 lanes, which would be total chaos on the traffic, since it's not a very good alternate route into town from the suburbs.
A nearby concrete highway with approximately 200,000 average daily traffic has performed beyond expectations, due in part to proper preventive maintenance.
That road is approximately 30 years old. It's 15 times its design life has been the number of loadings on that concrete pavement. We've diamond grounded in 1981 when we added a lane to the inside. At that time, we also did joint sealing. We have not touched that pavement since then. Diamond grinding is a process that we use to remove the faulting out of concrete pavements or to step off at the joints and to restore ride and surface texture. Basically, it's a machine that has approximately 60 blades per foot, diamond blades, and it really cuts grooves into the concrete at a certain depth, and the fins of the concrete will break off to give you that even surface.
When you see faulting, basically the slab basement material is being evacuated by water action and vehicle action, and it causes the slabs to fault or step off in a rhythmic thumping action that you get with the tires, and that means the slab basement material below it is now it's not supporting it any longer, it's shifting, and your slab is starting to move and then even crack.
If a concrete pavement has excessive faulting but still has significant remaining structural life, it may be a candidate for a minor rehabilitation technique, such as a dowel bar retrofit or full-depth pavement repair. Placing dowel bars or other devices across joints or cracks can restore good load transfer, thus improving pavement performance. Manufacturers and contractors are responding to preventive maintenance needs by developing new equipment and techniques to address a multitude of conditions. Improved technology for both hot-in-place and cold-in-place recycling now make these techniques viable options for preventive maintenance applications.
Often, cold-in-place and hot-in-place have not been considered as preventive maintenance treatments, but today we find more and more county and state agencies considering these treatments as part of the treatments that are in their grab bag of tricks.
Emerging technologies include multiple seal surface systems such as cape seals, double chips, and this example, a paver-placed surface seal or ultra-thin bonded wearing course. It places a polymer-modified asphalt emulsion underneath a thin, pre-coated, hot-applied, gap-graded aggregate.
Some of the applications we've seen where there's a lot of interest has been where there's minor rutting, some degree of cracking, again, less than a quarter inch or less as far as crack width. This does an excellent job of sealing that out.
The fast-curing properties of this treatment allow traffic back on the road almost immediately. Another new system that minimizes traffic delays features equipment which applies multiple seals to a road in one process: a crack sealing product, a sealing membrane, and a wearing course.
Well, in extending the pavement life, typically your first approach is dealing with the cracking problem, which this process obviously does by sealing the whole road surface and filling those cracks. By providing a wearing course and a sealing membrane, you will protect it from the oxidation process.
An effective preventive maintenance program requires a customized toolbox tailored specifically to address the unique conditions and needs of each state. Ideally, it should include a variety of treatments and techniques. Agencies may need to expand their contractor base and to foster, strengthen, and sustain opportunities for firms to respond to preventive maintenance needs. It should include survey and evaluation methods that assure consistent and accurate tracking of pavement performance, providing the data needed to make intelligent decisions on pavement selection, timing, and treatment. And it should include the administrative tools that allow agencies to act in a timely manner, both to identify candidates early in pavement life and to apply treatments within a short time after identification and project design.
We have to cast aside the construction mentality and quit looking at capital improvements in construction as the main program and start to address the customer's demands for preservation, improved mobility, and improved safety in the road.
The biggest challenge to establish a preventive maintenance program is to change the mindset of a lot of people. We need to begin looking at pavements in good condition and keep them in good condition. By starting slow and understanding the performance of the treatments and the cost-effective nature of the treatments, they'll begin to learn what benefits will accrue to the system.
And then you can figure out what your budget needs are. Then you can go to the legislature and fight for your funding and say, this is what it will take, this is what our history is showing, this is how long it's lasting, and there's the money that we need to maintain it at this level.
I think it's very important that we all work together as a team and share this knowledge. And it isn't that one tool is any better than the other, but we all need to work together to answer this question: what do I use and when do I use it and on what conditions?
It's got to be the right road, the right treatment, and the right time. Then states will start seeing the benefits of preventive maintenance.